Introduction to Algorithm. The topics in this presentation is referenced from the book Introduction to the Design and Analysis of Algorithm by Ananie Levitin. The topics discussed in this presentation are: what is an algorithm? What are the different types by which we can specify an algorithm? The process of algorithm design and analysis, and what are the different important problem types we face in computation. What is an algorithm? An algorithm is a set of unambiguous instructions to solve a problem to provide correct and expected output for all valid and legal input data. Let us see two algorithms to make a s'more. Algorithm 1. It uses a microwave. On a plate, add 1 graham cracker half, cover with a square of chocolate and marshmallow. Microwave for 15 seconds and top with another graham cracker half and the s'more is ready. Algorithm 2, which uses a stove. On a plate, add graham cracker half and cover with a square chocolate. Turn on the stove in high heat and hold the marshmallows until it catches flame. Put off the fire by blowing it off and turn off the stove. Put the marshmallow over the chocolate. Press the other graham cracker half over it and the s'more is ready. Now we have two algorithms to make a s'more. Now automatically the question arises, which is efficient? The efficiency of the algorithm depends on the resources currently available. Guidelines for writing an algorithm. The algorithm must have a name. The algorithm must mention input as well as output. The algorithm must be modular. The algorithm must be readable. So, what are the ways an algorithm can be written? The algorithm can be written using plain text, pseudocode, and any programming language. Let us discuss the algorithm for addition of matrices in the three ways of specifying the algorithm: the plain text, the pseudocode, and the programming language. Addition of matrices in plain text. The name of the algorithm is matrix addition. The algorithm receives input n1 and n2 as matrices. The output of the algorithm is the matrix out. Step 1. If the number of rows and the number of columns of n1 and n2 is equal, then add each value in n1 with the corresponding value in n2, matching the row and the column. Store the result in the matrix out. Step 2. If the number of rows and number of columns in n1 and n2 are not equal, display the error message. Addition of matrices in pseudocode. A pseudocode is a combination of plain text and programming language. The pseudocode does not have a syntax, but it uses specific keywords. For example, the begin and end given here represent the beginning and the end of a computation block. The pseudocode, like a programming language, consists of conditional and looping statements. Given here for addition of matrices, we have the if statement, which compares the number of rows with the number of columns for n1 and n2, and if they are equal, to two for loops are used to browse across the rows and the columns of n1 and n2, and addition of each element of the same column and the same row of n1 and n2 is performed and stored in the matrix out. And if the number of rows and columns are not equal in n1 and n2, the error message is displayed. Algorithm for addition of matrices in C programming language. The function matrix addition receives input n1 and n2 as matrices and the number of rows and columns as R and C respectively. It uses two for loops to browse through the rows and columns of n1 and n2 and performs addition of each element in n1 and n2 in their respective rows and columns and stores the result in the matrix out and returns the out matrix from the function matrix addition. We have discussed three ways by which an algorithm can be written, which are the plain text, the pseudocode, and a programming language. Now we will discuss the process of algorithm design and analysis. The flowchart given here explains this process. The first is to understand the problem and decide on the computational means for exact or approximate solution to the problem. Then design an algorithm for the exact or approximate output. Then prove the correctness of the algorithm, then analyze the algorithm, then code the algorithm. Let us discuss each one of them in detail. Let us discuss how we understand the problem thoroughly and the decision we make initially in the design of algorithm. To understand the problem thoroughly, read the problem description carefully and ask questions to clarify any doubts about the problem. Do a few small examples by hand and think about special cases, and again ask questions if needed. Asking questions and discussing helps to understand the problem in better way. Then decide on the capabilities of the computational device in which the algorithm will run as a code, but the principal decision is to choose between solving the problem exactly or solving it approximately. After understanding the problem and initial decisions, the next step is to design the algorithm and the data structures that are used with the algorithm. So, the algorithm design technique provide a powerful set of general approaches to algorithmic problem solving. Sometimes several of these techniques are combined to solve a problem, and there are algorithms that are hard to pinpoint as application of the known design techniques. That is, certain algorithms can use different technique to solve the problem rather than the known design techniques, and that is novelty. Attention to choosing data structure appropriate for the operation performed by the algorithm is essential. The varied data structure that we know are the linear data structure and the nonlinear data structure. Of course, recently we use a lot of sets, dictionaries, and graphs to solve problems in the internet. After the algorithm is formulated, it is essential to prove the algorithm correctness and analyze the algorithm. Prove that the algorithm yields a required result for every legitimate input in a finite amount of time. After correctness, the algorithm must be analyzed for efficiency. There are two ways in which the efficiency of the algorithm is analyzed. Time efficiency, indicating how fast the algorithm runs, and space efficiency, indicating how much memory it uses. Let us discuss two examples for mathematical computation. In each example, we will discuss two algorithms to do the computation, and also we will discuss which one is more efficient. The first example is to find the greatest common divisor of two positive integers m and n. The first algorithm is the algorithm we learn at school to compute the GCD. So this algorithm starts as finding the prime factors for the integers m and n. Then we identify all the common factors of m and n, find the product, and that is the GCD. So as an example, when we find the GCD of 60 and 24, the prime factors of 60 are 2, 3 and 5, and the prime factors of 24 are 2 and 3. Finding the product of the common factor, the GCD of 60 and 24 is calculated as 12. As you notice, finding the prime factors involves multiple divisions, and we compute the product of the common factor. So this algorithm has multiple steps. Let us discuss another algorithm to compute the GCD, which is called as the Euclid's algorithm. The Euclid's algorithm goes like this. If n equals 0, return the value of m as the GCD and stop. Otherwise, proceed to step 2. In step 2, divide m by n and assign the value of the remainder to r. Assign the value of n to m and the value of r to n and proceed with step 1. So to find the GCD of 60 and 24, we divide 60 by 24, getting a remainder of 12. Now 24 is assigned as m and 12 is assigned as n. Again, we divide 24 by 12 with the remainder 0, and 12 is assigned to m and 0 to n. Since n is 0 and m is 12, as per step 1, 12 is the GCD of 60 and 24. As you have noticed, this algorithm involves lesser step than the first algorithm which we learn at our school. Example 2 is to check whether a given number is prime or not. We'll discuss two algorithms to check whether a given number is prime or not. The algorithm 1 is a most familiar one, where if we divide by the numbers less than n, and if it does not leave a remainder of 0, then n is a prime number. If even for one number less than n, we get a remainder of 0 when n is divided by that number, then n is not a prime number. To implement this algorithm in a computer, we assign the variable n to the number, and is prime is a flag variable to indicate whether n is prime or not. Is prime is set to 1. Using a while loop, we loop across all the numbers less than n and check whether n mod I equals 0. If n mod I equals 0, we set is prime, the flag variable, to 0, indicating n is not a prime number. Then after the while loop, we check the value of is prime. If is prime is 0, we print that n is composite, else we print n is prime. Algorithm 2 to check whether a given number is prime or not. It is also called as the sieve of Eratosthenes. In this algorithm, let n be a given number. The sieve of Eratosthenes uses the postulation that n can be represented as a product of two numbers r and q, where one of them is less than the square root of n. Hence, in this algorithm, we find the square root of n and loop through all the numbers less than the square root of n and find whether n mod the numbers less than the square root of n equals 0. If it equals 0, then we set the is prime flag variable as 0, indicating that n is a composite number. If all the numbers less than the square root of n does not divide n, then n is a prime number. So we can see from these two algorithms, the algorithm 1 and the algorithm 2, to find whether a given number is prime or not. The algorithm 2 has reduced the number of steps in the while loop to the square root of n rather than the steps in the while loop in algorithm 1, which is equal to n minus 1. So, the number of steps in an algorithm decides on the efficiency of the algorithm. Algorithm 2 is more efficient than algorithm 1 to check whether a given number is prime or not. The algorithm is analyzed on three criteria: the efficiency, the simplicity, and the generality. The efficiency of the algorithm includes the time efficiency as well as the space efficiency. The time efficiency specifies how fast the algorithm runs, while the space efficiency specifies how much memory the algorithm uses. Simpler algorithms are easier to understand and easier to program. The generality of the algorithm is very important. It involves the set of inputs the algorithm accepts and gives a valid output. Here is a list of general problem types in computational algorithm. They are the sorting and searching algorithms, the string processing algorithms, the graph algorithms, which are very much used in the social networks, the combinatorial and the geometric and the numerical algorithms. In this presentation, we discussed what is an algorithm, how we write an algorithm using plaintext, pseudocode, and programming language. We discussed how we design and analyze an algorithm for a given problem. We discussed how the number of steps in an algorithm determines the efficiency of the algorithm, and also the criteria of determining the efficiency of an algorithm. We also discussed the important problem types in computational algorithm. Thank you.